Hello and welcome back. We have just two topics to cover in this short session: Boolean multiplication and addition and their properties. So we'll see that the Boolean AND operation can be viewed as multiplication and the Boolean OR operation can be viewed as addition. And we will look at that and compare the properties of these operations to the properties of addition and multiplication on natural numbers. The Boolean AND operation is equivalent to multiplication of natural numbers as long as we restrict ourselves to the two numbers 0 and 1. So let's look at all the four options. The AND operation is a binary operation taking two inputs. Therefore, we have four possibilities with two numbers in our domain. 0 and 0 is the same as 0 times 0 are natural numbers. The result is 0. 0 and 1 is the same as 0 times 1, just like 1 and 0 is the same as 1 times 0. Each of these equals 0. And 1 and 1 equals 1 times 1 is 1. So we can see that the Boolean AND operation is equivalent to multiplication on natural numbers, restricting ourselves to the numbers 0 and 1. Now, the Boolean OR operation is often called Boolean addition, and it is similar to the addition of natural and real numbers, but it's not exactly the same. Let's look at an example. The number 1 in a set of natural numbers. Let's add 1 plus 1. We know for natural numbers 1 plus 1 is 2. But if we define the plus symbol as the Boolean OR operation on the Boolean domain, 1 plus 1 or 1 or 1 equals 1. So this is where it's different from natural and real numbers. The other three cases where if we restrict ourselves to the numbers 0 and 1 in the set of natural numbers, we get the same result except when on both sides of the operator symbol we have a 1. So if we have a 0 and a 1 or a 0 and a 0 on either side of the operand, we get the same result. Let's take a look. 0 or 0 is equivalent to 0 plus 0 on natural numbers, and the result is 0. 0 or 1 is the same as 0 plus 1 on natural numbers equals 1, and 1 or 0 on the Boolean numbers is the same as 1 plus 0 on natural numbers, and it also equals 1. These three results are the same. The only exception is the last case, 1 or 1 equals 1, while 1 plus 1 equals 2 on natural numbers. So we can see that although we can use the same symbol for the Boolean operation OR as we do in addition of natural numbers, we're not doing exactly the same thing. We're doing something similar, but it's not exactly equivalent. So when we see an operator symbol, we have to take into account what set and what we're operating on and what algebra rules apply. We are free to reassign the plus operator symbol any way we like on different sets, and this is something that we must get used to when we are learning higher mathematics. So we had not yet looked at the properties of Boolean operations. And we'll see that both the AND and OR operations are associative. And that means that if we have two operations in a row, it doesn't matter which one we carry out first. So A and B and C, the result will be the same if we do A and B first or if we do B and C first. The same is true for the OR operation. So A or B or C, it doesn't matter if we do A or B first or if we do B or C first, we will get the same answer. Both AND and OR operations also are commutative. And that means we can switch the input sequence We can swap the operands. So A and B is the same as B and A, the same answer. Similar, A or B equals B or A. So both these operations commute. Now, in addition to this, both operations distribute over the other, and this is where we're going to see a difference with multiplication and addition of the natural numbers. Now that we know we can compare the AND operation to multiplication and the OR operation to addition, we will see that there is a difference here from addition and multiplication on natural numbers. So AND distributes over OR and vice versa, and that is not the case for addition and multiplication on natural numbers. Multiplication distributes over addition on natural numbers, but not the other way around. And we'll look at that a little bit more in the next slide. So let's look at the distributive property just a little bit more, and remember that we write OR as addition and the AND operation as multiplication. So we'll do that here so we can compare directly how this works with natural numbers versus the Boolean numbers. I've also used capital letters to indicate Boolean variables and lowercase letters to indicate variables in either the natural numbers or real numbers. But of course that's not a requirement. That's just to emphasize here which set we are operating on. So we know in natural numbers that multiplication distributes over addition. So A times in parentheses B plus C equals A times B plus A times C. This is not true for addition on natural numbers. A plus in parentheses B times C does not equal A plus B times A plus C. On the Boolean domain, however, both of these distribute. So Boolean multiplication, which is AND, distributes over Boolean addition, or the Boolean OR operation, and the Boolean addition also distributes over Boolean multiplication, so the OR distributes over the AND operation. So A times B plus C on the Boolean domain does equal A times B plus A times C, just like it does on real numbers, but A plus in parentheses B times C also equals A plus B times in parentheses A plus C, and this is not the case on either real or natural numbers. Let's spend a minute to summarize this session. So we saw that the Boolean AND operation is equivalent to multiplication, so we can also write it the same way we write multiplication of natural numbers. So A and B is the same as AB in short notation. And we saw the OR operation as addition, and we can write A or B or A plus B, just keeping in mind what set we're operating on. In this table, we're summarizing the properties of Boolean operations, and I've highlighted here where these properties are different from those of natural numbers, and that was the fact that the Boolean addition distributes over multiplication, unlike natural numbers.